Chlorination is a chemical disinfectant process that is used to combat waterborne disease. It is proven that chlorination is effective against bacteria and viruses. But do you ever wonder how much chlorine did we consume every day? Hello everyone, my name is Nuraisyah Adibah. In this video, I'll be presenting on the determination of trihalomethanes in drinking water using solid phase microextraction and gas chromatography electron capture detector. What is trihalomethanes? Trihalomethanes are volatile organic compounds that form during the water treatment process or chlorination process. It produced when chlorine combines with humic and fulvic acids that naturally present in raw water. We can be exposed to trihalomethanes through ingestion, inhalation, and dermal contact. It is known to be carcinogenic and hazardous to human health. Trihalomethane consists of chloroform, bromodichloromethane, dibromochloromethane, and bromoform. The analysis of trihalomethanes commonly performed with gas chromatography with detectors, mass spectrometers, or electron capture detector. For the extraction technique, the most commonly used are headspace solid phase microextraction, liquid-liquid extraction, or purge and trap technique. In the previous studies, liquid-liquid extraction and purge and trap technique have been used as an extraction method for the analysis of trihalomethanes in drinking water. By using these methods, trihalomethanes might lose during the extraction since trihalomethane is a volatile compound and only present in small concentration in drinking water. Liquid-liquid extraction also is a time-consuming technique that uses a lot of organic solvent and produces a large amount of organic waste, while purge and trap technique gives lower detection limit when coupled with gas chromatography. The headspace SPME proved to be sensitive, low sample size, and can be determined within a shorter extraction time with better recovery results. Thus, headspace SPME with CAR PDMS as fiber coating was used to improve the concentration of the trihalomethanes throughout the study. The significance of the study is SPME technique with CAR PDMS fiber coating can be applied in future research involving different samples containing trihalomethanes or other volatile compounds, and the finding of this study can increase the public awareness towards the possible presence of trihalomethanes in drinking water that they consume. The objective of this study is to evaluate the efficiency of CAR PDMS as SPME fiber coating in SPME technique and to determine the concentration of trihalomethanes in different drinking water samples using headspace SPME and GCECD. First, let's take a look at the properties of trihalomethanes. Trihalomethanes is an extremely volatile chemical compound commonly known as disinfection byproducts. Trihalomethanes formation can be influenced by temperature, reaction time, bromide and chlorine concentration, and pH. So, can trihalomethanes affect human health? The answer is yes. Long-term exposure has repeatedly been linked to a higher risk of bladder, colon, and rectal cancer. Trihalomethanes may also contribute in abnormal low birth weight and premature birth involving pregnant women. Trihalomethanes are produced when chlorine combines with natural organic material in raw water during the water treatment process. The oxidation of bromide to intermediates in the presence of chlorine allows the yields of trihalomethanes to increase. For the extraction method, headspace SPME is the most suitable method for analyzing volatile compounds due to its simplicity, high sensitivity, and solvent-free extraction. This technique involves sample collection, analytes enrichment, and separation of the analytes from the sample matrix. The analysis of water started with the standard trihalomethanes of 200 ppm dissolved in methanol to make a stock solution of 10 ppm and diluted into concentration ranging from 0.25 ppm to 2 ppm. Then 0.5 ppm was spiked with purified water with ratio 1:9. The headspace SPME method was evaluated using the optimum operating condition where the extraction temperature are 52 degrees Celsius, 20 minutes of extraction time, and 3 minutes of desorption time. 1 ml of drinking water samples were placed into the SPME vial and heated to 52 degrees Celsius. The CAR-PDMS fiber was exposed onto the headspace of the vial for 20 minutes. The trihalomethanes in water samples was determined by injecting the fiber onto the GCECD injector port set at 250 degrees Celsius. The method was validated based on linearity, limit of detection, limit of quantification, precision, and accuracy. Each compound in trihalomethane's mixture was well separated and eluted from the column at retention time of 2.9 minutes for chloroform, 3.7 minutes for bromodichloromethane, 5 minutes for dibromochloromethane, and 6.5 minutes for bromoform. The method was validated based on the linearity, limit of detection, limit of quantification, precision, and accuracy. Linearity is the ability to obtain the results that directly proportional to the concentration of analyte. The linearity of GC-ECD was determined by injecting the standard trihalomethanes range from 0.25 to 2 mg per liter. The correlation coefficient of trihalomethanes were found to be 0.9983 to 0.9992, showing a good linearity. In the study by Clayton, shows that the correlation coefficient ranged from 10 to 100 microgram per liter was 0.7453 to 0.9883 using HS-SPME. And in the study by Zhang, the correlation coefficient using CAR-BDMS fiber was higher than 0.999 with the range from 0.002 microgram per liter to 10 microgram per liter. The LOD obtained is between 0.1568 to 0.2242 mg per liter, while LOQ is between 0.4752 to 0.6793 mg per liter. LOD is referred to the lowest concentration limit for the analyte to be detected, but not necessarily be quantified or measured the exact value, while LOQ is the lowest concentration of analyte that can be determined by the exact value. For the accuracy, the percent recovery range from 71.2% to 85.5% was obtained, showing that headspace SPME using CAR-PDMS was satisfactory for the determination of trihalomethanes in drinking water sample, and the relative standard deviation was varied from 2.94% to 6.05%, indicating a good precision of the method. All trihalomethanes were not detected in mineral water 1, while in mineral water 2, only chloroform was detected at a very low concentration. Dibromochloromethane was not detected in mineral water and drinking water, while bromoform was not found in any water sample. Comparing the result obtained with the quality standard of trihalomethane in drinking water by World Health Organization and Ministry of Health Malaysia, the compounds present have exceeded the acceptable limit of trihalomethanes in drinking water. The research by Mohammad Faisal found that the concentration of trihalomethanes from water treatment plants in Perlis, Malaysia was in range of 0 to 0.5 mg per liter, which is lower than the result obtained in this study. An international study was conducted and found that among the countries, Australia was found to have the highest total trihalomethanes level with concentration of 250 mg per liter. The use of mostly groundwater source improved the treatment and distribution without the use of chlorine are some of the factors contributing to the lower level of trihalomethanes obtained in some countries. This statement supports why mineral water have little to no concentration of trihalomethanes. In conclusion, the analysis of trihalomethanes in mineral water, drinking water, and tap water using headspace SPME and GCECD involved the evaluation of CAR-PDMS as an efficient SPME fiber for the extraction technique and evaluating performance method. The percentage recoveries range from 71.2% to 85.5%, showing the satisfactory of this method. The validation of SPME technique was evaluated using optimum SPME operating conditions with 52 degrees Celsius extraction temperature, 20 minutes of extraction time, and 3 minutes of desorption time. The method validation observed were the correlation coefficient range greater than 0.99, LOD range from 0.1568 to 0.2242 microgram per liter and LOQ between 0.4752 to 0.6793 microgram per liter. From the results, it can be concluded that mineral water has very few or no trihalomethanes compounds, whereas drinking water and tap water have levels that are higher than the Ministry of Health suggested quality standard limit. It was recommended that future research identify other variables influencing the effectiveness of headspace SPME technique for analyzing trihalomethanes in water samples, for example, salt addition, pH, and many more. In order to obtain more accurate quantification of trihalomethanes in samples, internal standard approach should be used since it can overcome the detector response variability compared to the external standard approach. And lastly, the suggested turnaround time for trihalomethanes analysis is within 3 weeks. That's all from me. Thank you.